Hello, this is Mr. Best. Welcome to section 4.2, Trigonometric Functions, the unit circle part 2. In part 1, we dealt with angles in quadrant 1, and in part 2, we're going to deal with angles in quadrants 2, 3, and 4, and also angles on that are not located in quadrants that are called quadrantals on the axes. So the first thing is, what happens when we go outside of quadrant 1? So now we have our initial side and our terminal side larger than 90 degrees. So that represents theta. We're going to create a right triangle with the x-axis and the terminal side, and this right here represents what we call our reference angle. So that's your reference angle right here. And the reference angle here's definition is an acute angle formed by the terminal side, so it's always with the terminal side, the side that rotates, and the x-axis, positive or negative, just depends on where you're located. That represents the reference angle. That will help you identify what the ordered pair is. If you're in quadrant 2, you are moving to the left, so that's negative x and then positive y. So it'll still be a 30, 45, or 60 that we're going to be talking about, but it's going to be in a different location. So graph and label an angle and its reference angle. So once again, you have your initial side, and then 140 degrees. 90 is going to be that right angle, so 140. So this represents 140 degrees. But I want you to graph and label the angle, which we just did, and its reference angle. So the reference angle is going to be with the terminal side and the x-axis. And so this angle represents what? Well, if we know this is 180 degrees, then you can take 180 degrees and subtract 140 degrees to get 40 degrees as the reference angle. So from the negative x-axis to the terminal side, this represents 40 degrees, and that represents the reference angle for 140 degrees. So let's take a look at these 4 examples, and we're going to find the reference angle for each of the following. So 160 degrees. So you can kind of visualize this, but I'll kind of show you on each of those. If you graph 160 degrees, so 180 is here, so 160 somewhere in there. So that's 160 degrees. So what is the reference angle? Terminal side, x-axis. So that's 180 degrees. That's where that x-axis is, minus your angle of 160, and that gives you a reference angle of 20 degrees. And that's what you're looking for, that acute angle that is formed with the x-axis and the terminal side. What about negative 80? So negative is the direction, we're going clockwise. So this would be 0. This would be negative 90 degrees. So if you draw with the initial side, and it's not quite to negative 90, so this represents negative 80 degrees. Well, what's the reference angle? Well, the reference angle is with the terminal side and the x-axis. That gives you the acute angle. So the reference angle actually is exactly the same angle there, but it would be a reference angle of 80 degrees since we don't have negative reference angles. So that represents 80 degrees as our reference angle. On part C, we're dealing with radians, but it works the same way. 5 pi over 8, so you have your initial side, 5 pi over 8, this represents pi, or 8 pi over 8. And so 5 pi, or 5/8 of a pi, 4/8 would be a half, so 5 pi over 8 would be somewhere in there. And so now you want to take pi units and subtract 5 pi over 8 to figure out what that difference is when you're looking at the terminal side and that x-axis. So we're going to take pi minus 5 pi over 8, find a common denominator, 8 pi over 8, minus 5 pi over 8, which would give you 3 pi over 8. So your reference angle is equal to 3 pi over 8. And then the last one, negative 4 pi over 3. So now this one, you'll have the initial side still in the positive x-axis. You're going in the clockwise direction. That's 1 1/3. So this is 1 pi radian, and then 1/3 is somewhere up here. So that represents negative 4 pi over 3. The reference angle is, once again, terminal side and x-axis. So it's that angle right there. So if we're going to subtract, this is negative pi, we can take the larger value, which would be negative pi, and subtract negative 4 pi over 3 to figure out what that reference angle is. So once again, common denominator, minus negative 4 pi over 3, you would change to addition. And so that would be 4 pi over 3, which gives you a reference angle of pi over 3. And so that's how you find the reference angle. Always go with the terminal side and the closest x-axis. It always has to be that acute angle. Never go with the obtuse angle. Always the acute angle with the terminal side and the x-axis. Okay, so what happens when we go outside of quadrant 1? So if we start with the ones that we worked with on the part 1, such as this one right here being 30 degrees, or pi over 6, it's a sixth of 180. It gave us the ordered pair square root of 3 over 2 comma 1/2. Well, what happens if we have this reference angle right here as 30 degrees? Okay, so we're still going to create that same triangle where you have the hypotenuse 1, the short side would be 1/2, and then square root of 3 over 2. That's where that ordered pair came from. But on this one, the same thing is going to happen. You have the hypotenuse 1, the short side is 1/2, but the long side is now negative square root of 3 over 2 because of where you are located. So these ordered pairs represent what those sign values are for each of the trig functions that we'll be dealing with. And so you can see it has a negative with the x. When you go down here and create this triangle, this has a reference angle of 30 degrees still. But now your ordered pair right here, because you're in quadrant 3, has negative square root of 3 over 2 and negative 1/2. And then you can do the same thing in quadrant 4. So this right here represents 30 degrees. And then this ordered pair, same ordered pair, but because you are in quadrant 4, it's a positive x and a negative y. And that works for all your 30, 45, and 60 degree angles. So you could do the same thing with this one up here, is that you have square root of 2 over 2, and then now you have this one, it's square root of 2 over 2, but the x value is negative because of where you're located in the quadrant. Same thing for this one down here, you're in quadrant 3, so they'll both be negative. And then this one you are in quadrant 4, so x will be positive and y will be negative. And so it's all going to be based on location as we go through this. We'll talk about these quadrantals in just a little bit. Okay? But the 30, 45, 60, those 9 different angles there, at 3 in each quadrant, are going to be our main focus as we move through these exact values. So now we're going to do the same thing we did the other day, but now these angles can be located anywhere on the unit circle. So sine of 135 degrees. To be able to figure out what a sine of 135 degrees is as an exact value, no calculators, then we need to know these 3 things right here. We want to know what the reference angle is, where it's located, and what that ordered pair is so that we can answer the question. So what's the reference angle of 135? So that's over here, that's 135. So what represents this angle that's left to get to 180? And that would be 45 degrees. 180 minus 135 is 45. So our reference angle is 45. You can see it's located in quadrant 2. The ordered pair for 45 is square root of 2 over 2, square root of 2 over 2. But because you are in quadrant 2, x is negative and y is positive. So your ordered pair is negative square root of 2 over 2 and positive square root of 2 over 2. And then you got to answer the question. Now that you have all this listed out, you can answer any of the 6 trig questions. Cosine is your x, sine is your y, tangent is your sine divided by cosine, and then you can use the reciprocals for the other 3. So this one's saying sine of 135 degrees. Okay, and so since it's sine of 135 degrees, sine represents the y value. So of the ordered pair, it's square root of 2 over 2, and it will be a positive square root of 2 over 2. And there you go. All right. Cosine of 300. So 300, you have 90, 180, 270, 300 right there. What is that reference angle right here? Well, it's 360 is a full rotation. You've already gone 300 degrees, so what's that difference? 60 degrees. So your reference angle 60. Your quadrant, you can see that you're located in quadrant 4. And then the ordered pair for 60 degrees is 1/2, comma, square root of 3 over 2. But you're located in quadrant 4, which has a positive x and a negative y. So if you're plotting a point, it's positive x and then down, which is a negative y. So it'd be 1/2, comma, negative square root of 3 over 2. So cosine of 300 is, cosine is your x value, which in this case would be 1/2. So cosine of 300 degrees is 1/2. Here's the end result. This is what we're looking for. What ratio for that angle in terms of sine and cosine? Okay? And then we just continue on and continue to look at these. So tangent of negative 30 degrees. So that one you might be able to visualize a little bit more, but you'll get better at this. So negative 30 would be right here, but that also represents exactly the same reference angle, which is right here. So your reference angle is 30 degrees. You are located in quadrant 4, and your ordered pair for 30 degrees is square root of 3 over 2, comma 1/2. But you are in quadrant 4, so x is positive, y is negative. So that 1/2 needs to be negative. Now you need to answer the question, what is tangent? Tangent is sine over cosine, or y over x. So you will have negative 1/2 divided by square root of 3 over 2. So the 2's cancel, and you're left with negative 1 over the square root of 3. And so when you rationalize that, that's negative square root of 3 over 3. So tangent of negative 30 is negative square root of 3 over 3. And so that's the ratio for any negative 30 degree angle there.